Hello, my name is Anish. Welcome to FEMAS. And in this video, I'm going to talk about Newton's laws, the first law and second law specifically. The first law says that an object at rest stays in rest, and an object in motion stays in motion until or unless disturbed by an unbalanced external force. And the second law says that force on an object is equal to its mass times into its acceleration, F equals ma. Okay, now I'm going to walk you through a small derivation that you must have come across in your school physics if you're a science student. Let's see. This is Newton's second law, F equals ma. In the absence of external force, ma becomes zero. Since we are assuming that mass is non-zero, we conclude that acceleration is equal to zero. Now, what this derivation says that when there is no external force, the particle will move at constant velocity or will stay at rest. This is exactly what Newton's first law say, that the particle will continue at constant velocity in a straight line until or unless subjected to non-zero external force. So we just extracted the first law from the second law. My question to you is, doesn't it make the second law more fundamental than the first law? And if that's the case, then should we just study or keep the second law in Newton's laws of motion? Think about it for a moment and comment your answer. Those of you who are confused, stick to this video, and by the end, you will realize and appreciate how fundamental uh, the first law is when it comes to give meaning to motion, and how poor uh, job our textbook do in explaining the first law or second law or third law. To present my argument, I'm going to give you two analogies, one from mathematics and one from thermodynamics. Let's do it. In mathematics, we have numbers and arithmetic, which is subtraction, addition, multiplication. But before you talk about numbers and arithmetic, you have to define zero. Similarly, in physics, the second law is about uh, change in force, change in motion. But before you talk about that, you have to define what zero acceleration and zero force mean. Uh, Now, let's come down to thermodynamics. The first law of thermodynamics is about energy conservation, which involves internal energy, work done by or upon the system, and heat flow. But before you talk about that, you have to define temperature. And the zeroth law of thermodynamics does that. The zeroth law of thermodynamics says that if there is system A in equilibrium with system B and the B is equilibrium with C, then A is equilibrium with C. Okay. It doesn't define heat flow, but it defines temperature as a measurable quantity. Similarly, in physics, the second law defines force relation with acceleration. But before you talk about that, you have to define inertial frames where motion has meaning. Okay. So these two analogies must have given you some idea about how important or fundamental the first law is if you want to talk about motion. Basically, the first law set the stage where the second law makes sense. The first law identifies the class of frames in which no force really means no acceleration. And the second law then quantifies how acceleration rises when forces are present in those frames. If I have to summarize in a statement, I would say Newton's first law established inertial frames by stating that the free particles move with constant velocity in those frames. This provides reference structure where acceleration has an unambiguous meaning. Newton's second law then relates uh, acceleration to real forces in those frames. Thank you.